tells you what to do. It says to check the conditions for inference first. So remember, the first two conditions are the same as they are for proportions. So what's the first condition?
Random.
Yes. A random sample. This wasn't random. Does it seem representative? If we're talking about high school students, are you representative of high school students, you think?
Yes.
Probably. Okay, and then the second condition is also the same as for proportions. So, second condition, less than 10%. So there's 17 people here today. You think 17 is less than 10% of all high school students?
Yes.
Yes. Okay, the third condition is the different one that's different from proportion. It's also the hardest to check. So if you need to look back on, where is it? First page. Okay, it's called the nearly normal condition. There's two ways to check this. The easiest way is if you have a really large sample, you can just say it's a large sample size. But we're saying at least 25 to 30 is considered large. So do we have a large enough sample size? No. So unfortunately, we have to see if it's approximately normal. So to do that, it has to be a unimodal and symmetric distribution. And the only way to do that is to factor it. So how would we create a histogram? This is a great review of this data. So the first semester stuff. Yes. So to start, let's make a list. One list and just type these numbers in. Okay, just in case. So you have a list. How do we make a histogram? Okay, yeah, you go to the stat plot right above y equals, so second y equals. We're going to turn it on and then pick the one that looks like a histogram. Histograms are like a bar graph, sort of. And your X list should say L1, and it probably does. If you just hit graph, you're probably not going to see, that is not statistics. You're probably not going to see the graph at all. So we did this a long time ago. You hit zoom stat, I think it's number 9, zoom stat, and then you should be able to see it. Did anyone's look different? Yeah? Okay. What are you trying to do?
Type in the numbers and
Okay, type in the, so I'll go back over. So you have the numbers typed in, then you go to second y equals, turn it on, pick the histogram, and it's L1, and then zoom 9, zoom stat. Did anyone's like mine? Okay. Now, is that unimodal and symmetric?
no.
Not very good. What if we threw out the last category? Yeah, that would be really good. This condition. Okay, if you're taking the A/B test, it's probably going to be unimodal and symmetric, so you just need to find a way to make it that way. Or a lot of times they'll have the graph already there for you, and so all you have to say, the histogram is unimodal and symmetric. We're using real life data, so really no, this isn't very unimodal and symmetric. But it's not horrible. It's not like it's bimodal or extremely skewed. We could, I could play with the window a little bit, Right now it's from 19 to 56. I could go from, I don't know, 15 to 60, go up by 5. And I could just do some different things and play that. Eventually it would probably be unimodal and symmetric or a lot closer. Like that one's not too bad. It's not great. But I don't usually want you spending that much time. So I could go from 10 to 60. Oh, I messed up. Anyway, once you get a histogram, just sketch it. And unless it's just absolutely horrible, we're going to say it's unimodal and symmetric. So, you don't have a whole lot of space. Okay, just quickly sketch it. That was awful. There we go. And you can say the histogram is roughly unimodal and symmetric. And also, the sample size has a little bit to do with how picky you are about the histogram. The closer the sample size is to 30, which 17, we're getting pretty close to 20, it has to be less unimodal symmetric. Like if you use samples of size 5 or 3, then it needs to be extremely unimodal and symmetric. The smaller the sample size, the more accurate you have to be. This one's pretty big sample size, so we're probably fine. Okay, so now it says find the mean and standard deviation. How do we do that? Another review. It's not given to us, so we have to do some sort of calculation.
Well, add up all the.
Okay, we can add them up and divide by 17 for the mean, but the standard deviation's a big long formula. So if you want to do them both at the same time, stat,
One variable stat.
stat, one variable stats.
Oh.
Oh yeah. I mean, you can do all those formulas if you want to, but let's make it easy. Stat, one variable stats, and it's L1. The mean is 34.6. So the mean of this sample, I'm using X bar because it's from the sample. Where the calculator is dumb. It doesn't know if it's a sample or the population. So you have to decide. This is a sample. And then the standard deviation of the sample. Your calculator gives you two standard deviations. SX is the standard deviation, and so is the sigma right underneath that. So which one do we need to use? SX, because it is the sample. There's a slightly different formula if it was the whole population. Okay, any questions? Anyone have trouble? Here.
I can get 34.4.
Really?
I got 37.4.
We did before.
I got 34.2.
I got
Yeah, I got 34.2.
Let me check my numbers.
But
I got
it's weird because it says list 1 and it says frequency list.
Oh, okay.
And then I tried
If
to
it says
type one.
frequency list, mine doesn't say that. That's why I didn't think about it. Just make sure it says 1, not L1, just 1.
When I do 1, it gives me Y.
Click alpha 1.
Okay. Did that work?
Nope.
Did you
Or second.
Yours says that too?
Alpha 1 worked.
No? Alpha 1.
To change it to
But then it says error. Yeah.
okay, never mind.
I don't know. We'll figure it out in a second. Okay. We'll just go and figure it out, but yeah. There should be a way to fix that.
They may have their calculator set on something else.
No, it's just, I don't remember. I'll figure it out. Okay, so let's create and interpret a 95% confidence interval. So you can use the calculator, yes, but I'm going to show you the formula anyway. So let's go through the little pink sheet I just gave you and make sure we do all the steps. So the first thing, first letter of panic, is the population parameter. So what are we trying to estimate in this confidence interval? Yeah. Right? And so you just say that. So it's basically saying what we're doing. We're creating a confidence interval for the mean number of movies watched. It's really the population mean, but if you don't say sample, it's kind of the same as population. So it's a confidence interval for the mean number of movies watched. The assumptions, those are the same thing as conditions. We've already checked those, so that's good. So the name or the formula. So our name is a one sample t interval. In your calculator, again, it just says t interval, but the name is a one sample t interval. So if you are going to use your calculator, you have to put one sample t interval. Okay, I'm still going to do the formula this time. Let's see. So where is it? There it is. So the formula is pretty simple. We've already found all the important parts. We have x bar plus or minus our t star. We need to talk about how to find that again. Anyway, and then the standard deviation divided by radical n. So it's x bar, so 34.6 plus or minus. We'll look up the critical value. And then standard deviation divided by radical n. What's n? 7. Okay, so someone who was here yesterday, how do we find that t star?
N-1.
Okay, n minus 1 is 16. So if you weren't here, you go to table B on your bright orange chart. And on the left, it says DF. That's called the degrees of freedom. So you find 16 on the left. And then we're doing a 95% confidence interval. 95% is at the very bottom, and you just match those up. So it is 2.12. Yes.
Back with the orange chart, there was a way to do it in the calculator. Is there a way to do that without?
It's not easy. So you really won't have to do it that often, because usually you're just going to go straight to your calculator. Okay, so you can either use this formula, add and subtract, or now I'm just going to go to the calculator. So so find one sample. Why am I forgetting what to do? Oh yeah, the test. So it's a t interval. Make sure you pick t interval and not z interval. Ooh, let me show you this one. There's two ways to input information. Probably, if your calculator is like mine, when you went to it, since we had just entered information into a list, it saved that information. Look, that's the same mean and standard deviation that we just found. Did anyone else do that?
Yeah.
Yours didn't? That's sad. Oh, does yours say data? Okay, go over to stats. So there's two ways to enter the information. If you have a list, you need to pick stats. If you're not given a list, and we'll do one of these next week, and why does it hold on. That's not true. Mine just saved it. Why did it do that? Now I'm confused. So on mine for data, it actually saved the list. So you could do that too. And then if it was stats, was anyone's blank and you had to type it in? No? Okay, so it saved it. If this is ever blank, you can just type in the mean and standard deviation. So it should work.
What's our confidence
Either one.
level? 95?
Yes, I hadn't changed it. So it's a 95 confidence interval, confidence level. N is 17. And then you just calculate. that is the interval. So 29.36 to 39.82. And then what do you always do after you write an interval? Interpret. Unless it specifically says do not interpret, you always assume if you have an interval, it needs to be interpreted. Always. Okay? Hopefully you have one more space. So we are blue one, it is awful. So we are 95% confident that, what do we mean 95% confident of?
You rounded everything.
That the mean number of movies watched by high school students is between 39.36 and 39.82. Are you guys having trouble?
We always talk about
Okay. Okay, so if I said, I don't know, people claim that high school students have watched half of the top 50 movies. Would this interval support that conclusion? High school students have watched, okay, but if I said have watched at least half the 50 movies. Yes, at least half, yes, they've watched a lot more than half on average. Okay, and if I said no more than half, then this would not be right. Or this would not support that. Questions? That's the main thing for what you learned today. Okay. So this is just a few additional questions that go with confidence intervals. Should be review. It's stuff we've done before. This is explain what 95% confidence means. This is not the same thing as the we are 95% confident. That's interpreting the interval. This says interpret the confidence level. What does that 95% confident? What does this part of the interpretation mean? Anyone remember? Starts with 95%.
95% data lies in 2029. Can be explained that.
Oh no,
About that.
that's no. How do you do
Can
that?
be explained by.
Okay. It's just 95% of all random samples. Remember, this is just one random sample. We used one random sample to capture the whole interval, to try to capture the actual population mean. So it's saying 95% of all random samples, 95% wouldn't capture or wouldn't use that exact same interval. That's only for that one sample. But 95% of all random samples would capture or estimate the true population mean. Okay, so for example, I'm going to get another sample in my fifth hour class. That's another sample. If these two are in the 95%, that sample probably will not give me the exact same interval. It'll probably be different. But if it's close, it could still estimate the population mean. Does that make sense? And if we kept doing this forever and ever, infinity, then 5% would estimate bad means. They wouldn't be the right mean. Okay, but 95% of them would be correct. Okay, what's the margin of error? There's two ways to find this. We did one way yesterday. If you use the interval, how could you use the interval and find the margin of error? Just did it yesterday. Yeah, just find the difference and then divide by 2. Since I have this formula written down, you could also use the formula. Margin of error is everything after the plus or minus. So 2.12 times 10.2 divided by radical 17. Can I put 47 in? Look, that's got to be about right because 39 to 29 is a little more than 10, so half of that's a little more than 5. Okay, last one. It asks, how large a sample would you need to estimate the mean number of movies to within 5 movies with 99% confidence? So, if we're going to estimate to within 5 movies, what is that? The margin of error. So we're saying the margin of error equals, then we want to use everything after the plus or minus, but we're not using that data because now we have we're trying to find a new sample size.
So we challenge question.
I'm just writing down the formula. See what we need to know. Okay, is there any of this that we already know? We're trying to find radical n, so don't tell me that. Okay, standard deviation was 2.2. Oh yeah, 7.2. So say if we're getting a new sample, we want to be within 5 movies of the actual population mean. Now, this, we're not going to, the t-star is based off of n minus 1, and if we don't know what n is, we don't really know how to find the t-star. So if you're trying to find n, you need to use z-star. That's to infinity. That's like the worst possible case or the best possible case, how I'm going to look at it. Okay, so someone who has their table out, look up 99% confidence, the very bottom row, where the z-star is.
2.5, 7, 6.
2.5, 7, 6. Now it's an algebra equation. We can solve it. What would be our first step to solve this equation? Oh, what? Divide by 2.576. We did some of these a long time ago. The trick on this is you don't round until the very end. So you leave it in your calculator. So in your calculator, go ahead and do 5 divided by 2.576. It'll give you a long decimal, it's 1.94 and a bunch of decimal places. You can write 1.94 down, but don't round yet. Okay? Now, how do we solve the rest of this? It's a proportion.
Would you square it?
Well, this one's a little different than the proportions. In the proportions, we did square everything because the whole thing is in a radical. Since 10.2 is not in a radical, we don't want to square yet. We'll multiply by radical n. Testing your algebra knowledge on solving radical equations. So now what?
Divide by.
Yeah, divide by the 1.94 or whatever. So radical n equals. Okay, so now let's go back to your calculator. So 10.2 divided by what you saved in your calculator. So 10.2 divided by the answer, the last answer you had. And mine came out to be the exact number. I mean, rounded. And then there's just one more step. Square both sides. And then you can find finally round. At the very end, this is a sample size, so round to the nearest whole number. So about 28. 28.